So, hello everyone again. This is lecture 4 part 2 of wave optics. Let us begin the discussion more on constructive interference and destructive interference in this chapter. In the last lecture we concluded about the concept, if the perpendicular bisector exists between S1p and S2p, then how will be the intensity, that is always equal to 4 I naught, where I naught is directly proportional to A square. So, let us move on with our discussion. I am Sameer Lavankar. Let us begin. So, this is the course outline. We have concluded the first thing, second Huygens principle, refractive and reflection of plane waves using Huygens principle, and right now we are in coherent and incoherent addition of waves. So, this is the concept we explained, I already explained to you in the last point only. Today let us move on with this next line. So, this was the last explanation being done in the last lecture. Now, let us move on with this second point here. So, the two sources are said to be interfere constructively, that is constructive interference, and we have what is referred to as constructive interference. So, what does constructive interference is? Two sources are said to be interfering constructively, and we have what is referred to as constructive interference, that will be explained in subsequent points now. So, just look over here carefully now. So, now let us consider a point Q. So, this is that point Q being talked about here in the figure right towards you. So, for which S2q minus S1q is equal to 2 lambda. So, just for a simple explanation, what does lambda here mean is? So, this much is only required for now. So, this is nothing but the amplitude being talked about here, and this is the complete wavelength, that is the time required for this to complete one complete cycle is nothing but the distance required. The distance required for the sinusoidal wave to complete one complete cycle is nothing but called as a wavelength. So, also being talked about here only. So, what does it say is key, let us suppose I explain just for an example, it is written here. So, let us suppose that S1q is 7 lambda, and let us suppose that S2q is equal to 9 lambda. So, it is quite evident that S2q minus S1q is nothing but 9 lambda minus 7 lambda, which is equal to 2 lambda. So, now what does this try to imply is, what does here point Q explain is? So, just let me explain. So, here what we are assuming is, we are assuming some point Q here only on the calm pool of water. So, we are just measuring these distances like this, but now we are measuring it as a function of wavelength. So, now we next consider point Q for which S2q minus S1q is equal to 2 lambda. The waves emanating from S1 will arrive exactly 2 cycles earlier than the waves from S2 and will again be in phase. So, let me explain you again. So, now it is just nothing but a theoretical explanation of this point only. So, waves emanating from source S1 will arrive exactly 2 cycles earlier. So, quite evident, if the distance is small, then the amount of time required will be small if the medium is being considered same. So, here it is written here that S1q is equal to 7 lambda, S2q is equal to 9 lambda. So, what does it say is, if the S1 arrive exactly 2 cycles earlier, quite evident is because the cycle number of cycles is less for source S1, hence it is that it exactly arrives 2 cycles earlier than the waves from S2 and will again be in phase. Why will it be in phase? Because the time lag or the point of difference of the displacements at the points will always be 0. So, either at lambda, 2 lambda, 3 lambda, 4 lambda, at any multiples of lambda the displacement will be 0, hence it always will be in phase. So, what does the phase exactly concept here mean is, if we are finding out a particular time at which the displacement is same from the source S1 and source S2, then that two sources are called to be in phase. So, what does here phase tell us? Because at the end of each wavelength the displacement is 0 for at say 7 lambda also, at say 9 lambda also. That is why it is being explained that the two wavelengths the two sources are in phase. Thus, if the displacement produced by S1 is given by y1 a cos omega t, now we are explaining it, that let us suppose the displacement produced by S1 is given by y1 is equal to a cos omega t, then the displacement produced by source S2 will be given by y2 is equal to a cos omega t minus 4 pi. Why there is a minus 4 pi here? There is a minus 4 pi here because we need to calculate at some different phase. Because the phase is same which is being calculated here, but now we need some different time, like we need some different experience because the amount of time is different. Why it is different? Because it appears earlier, it appears after. The time required is not same for both, but the phase is same. Please make sure time is not the same, phase is same. To make the phase same, how we are explaining this concept here mathematically? We are explaining it by denoting some different 4 pi here. Why it is a minus 4 pi? Because y2 requires lesser time, sorry, y2 requires more time, that is why. So, y2 is equal to a cos omega t minus 4 pi. From mathematical formulation we know that at with increase, sorry, so let me write it here only. So, cos omega t plus minus n pi is nothing but cos omega t. So, just putting any n value here and any sign value, we always get cos omega t. Hence, we found out the value of displacement here also as nothing but this a cos omega t. So, if we find out this a cos omega t, then it is quite evident that the intensity again we will get is 4 I naught. Hence, same concept is being talked about again here only, where we have used the fact that the path difference of 2 lambda corresponds to a phase difference of 4 pi. So, as a path difference of lambda corresponds to a phase difference of 2 pi, therefore, a path difference of 2 lambda corresponds to a phase difference of 4 pi. Hence, a path difference of n lambda corresponds to a phase difference of 2 n pi. Simple mathematical formulation, simple mathematical concept. So, let us move on, where we have used the fact that a path difference of 2 lambda corresponds to a phase difference of 4 pi. So, how do we convert this path difference into phase difference is being conceptualized here in this complete mathematical formulation above. Therefore, the two displacements are once again in phase. Why it is in phase? Because the displacements are being calculated same, and also the displacement at a particular time was 0 when the wavelength was being completed. The two displacements are once again in phase, and the intensity will again be 4 I naught. Why it is 4 I naught? Because y1 value is equal to y2 value and y1 is equal to 2y. Hence, we can this, let us say the intensity at y1 y2 is I naught, then the intensity at the combination of the resultant displacement will be 4 I naught. So, now the two displacements are once again in phase and the intensity will again be 4 I naught, giving rise to constructive interference. This was the complete concept we talked about here also. Here, so why when it was 4 I naught, and it was explained that these two sources, above two sources were called as were said to interfere constructively, and we have what is referred to as constructive interference. So, this was nothing but the concept of constructive interference, quite evident as we can explain it from the wordings also. It is known as constructive. So, there is a construct of two things. Destructive is something will be cancelling each other, and hence the intensity will not be 4 I naught. What will be the actual value? We will know in subsequent points only, but for now, from the last two discussions, first of all the discussion of S1p and S2p, where S1p was equal to S2p, and also from this discussion that if the path difference is a multiple of 2 lambda, 2 means a multiple of lambda, that is the complete lambda value is being constructed, then that means that there is a phase difference of 2 pi, and because there is a difference of 2 pi either plus or minus, always the cos value will be cos omega t again, and if the value is cos omega t again, then that means y1 is equal to a cos omega t, similarly y2 is equal to a cos omega t, and therefore, the resultant displacement will be y1 is equal to y1 plus, sorry, y is equal to y1 plus y2, which is equal to 2a cos omega t, and therefore, that intensity would be 4 I naught, where I naught is the intensity of a single source. So, this was the complete concept of constructive interference. Moving on to now destructive interference. What does destructive interference talk about here is, so now in the above analysis we have assumed that the distances S1q and S2q, let me iterate again. So, in the above analysis we have assumed that the distances S1q and S2q are much greater than d, which represent a distance between S1 and S2. So, what does S1 d explain? Just to let me explain to you what is S1 S2 d here. So, this is that distance being talked about, this is the distance d, this is the distance d, and it is written here that these distances, that is S1q and S2q, let me write different only, are greater than d. Similarly, S2Q are greater than capital small t, sorry. So, in the above analysis we have assumed, so this is also an assumption. This is also an assumption we talked about here. So, in the above analysis we have assumed that the distances S1Q and S2Q are much greater than small d, which represent the distance between S1 and S2. So, that although S1 and S2Q are not equal, the amplitudes of the displacement produced by each wave are very nearly the same. So, this is only the explanation. The explanation is quite evident from the wordings only. So, because even if S12 and S2Q are not equal, the amplitudes due to them would nearly be the same, because there will not be any interference in the portion where the D is happening. Because of that, and because the length, this length is great, there will be no effect due to different source being explained in the nearby position. So, that although S1Q and S2Q are not equal, the amplitudes of the displacement produced by each wave are very nearly the same. So, this is also being done. Now, to explain the destructive interference, please look over here carefully what is happening. So, now we next consider a point R. So, now point R is being used here. So, what does this point R says? For which S2R minus S1R is minus 2.5 lambda. That means, if we write it as like this, then it is S1R minus S2R is equal to 2.5 lambda. That means the time required, the distance of S1 from that point R is more than distance of source S2 from point R. So, quite evident from the figure also. For an example, it is written here is, let us suppose that S1R is 9.75 lambda and let us suppose S2R is 7.25 lambda. So, what does S1R minus S2R corresponds to? By mathematical calculation, it is 2.5 lambda. So, because it is 2.5 lambda, that is there will be a phase difference. Why there will be a phase difference? Because the complete value of wavelength is not being completed. That is why the displacements observed by y1 will be different from displacement observed by y2. Why it will be different? Because as you can see from mathematical formulation also, cos omega t minus 4 pi was there when constructive interference was happening. But here there will be a difference of values. It won't be a multiple of 2n pi. It will be, let us suppose 5 pi, 3 pi, 2n plus 1 value would be there. That is why there won't be constructive interference now. So, what will be here? Let me explain to you now from the next line here. So, now this thing is done. So, now the waves emanating from S1 will arrive exactly 2.5 cycles. So, 2.5 cycle later than the wave from source S2. So, this is the same concept explained like in the constructive interference only. Next, thus if the displacements produced by S1 is given by y1 is equal to a cos omega t. So, first assumption is, let us suppose that y1 is equal to a cos omega t. Then the displacement produced by S2 will be given by y2 is equal to a cos omega t plus 5 pi. Why there is a plus here? Because this time S1 distance was larger. Previously S1 was smaller. That is why there is a difference in the sign convention and hence the value of plus is being used. Last time it was a distance of negative value. And why there is a 5 pi? Because 2 lambda corresponds to a phase difference of 4 pi and a complete lambda corresponds to a phase difference of 2 pi. Therefore, lambda by 2 will correspond to a phase difference of pi. Therefore, 4 pi plus pi is equal to 5 pi, and hence we calculate the value of pi. Just to explain to you by writing it also. So, we know that a wavelength a path difference of 2 lambda corresponds to a phase difference of 4 pi. Similarly, a path difference of lambda corresponds to a phase difference of 2 pi, and similarly lambda by 2 corresponds to a phase difference of pi. So, using the, let us say I use this and this equation, what I will get is 2 lambda plus lambda by 2 is nothing but 2.5 lambda, and hence the value of phase difference will be 5 pi, which is being used here. So, this was the explanation of why 5 pi is being used. So, now we know from simple mathematical formulation that cos of omega t plus minus 2n plus 1 pi. So, 2n plus 1 pi is nothing but the odd numbers is equal to minus cos omega t. Hence, we will get y2 is equal to minus cos omega t. Now, when we calculate, when we find out the value of displacement, we will get a value of 0. Here we have used the fact that a path difference of 2.5 lambda corresponds to a phase difference of 5 pi. This has been already explained by mathematical calculation also in the last slide. Now, the two displacements are now out of phase. Why are they out of phase? Because they do not have the same value of a number which is after this plus value. So, for first displacement it was my y1 is equal to a cos omega t, y2 is equal to minus a cos omega t. Therefore, y is equal to y1 plus y2, which is 0, and the two displacement will cancel out to give 0 intensity. So, this was a simple concept, as the intensity is always proportional to the square of the amplitude. Therefore, as I is equal to 0, hence this thing is proved that it has 0 intensity. So, this was the concept here only. Now, this is referred to as destructive interference. So, now as from the figure, as from the number name also you can directly conclude the statement. So, what was constructive interference? When the phases were being intact and the summation of the displacements lead to the multiplication, that is the intensity being increased from I, it was increased to 4 times, that is 4 I naught. Similarly, in destructive interference what is happening is, because they are cancelling each other, because they are destroying each other, it is known as destructive interference. So, these were the simple concepts of destructive and constructive interference. So, now to conclude everything, how everything which we have learnt in the complete 2-3 slides is being explained here. So, now please look over here carefully. Hence, if we have two coherent sources, what does coherent sources mean? Coherent sources mean any two sources which have the phase difference which does not change with time. That is the phase. Let me explain to you by writing here only. So, the phase difference between the two displacements produced by each of the wave does not change with time. So, when the phase difference does not change with time, then those two sources are called as coherent sources. Similarly, if the phase difference between the displacements which change with time, then those are known as what we can say incoherent sources. So, moving on. So, now just explanation again. So, hence if we have two coherent sources S1 and S2 vibrating in phase, quite evident coherent sources will vibrate in phase only. Then for an arbitrary point P, wherever the path difference is, that is S1 P minus S2 P is n lambda. N lambda is, that is always a multiple of lambda. Let us suppose n lambda, 2 lambda, 3 lambda or so on. So, as in this figure also it was a multiplication of n lambda only, where n was 2 here. Hence, a constructive interference example was being performed, and therefore, we have constructive interference. We have what is something called as constructive interference, and the resultant intensity will be nothing but 4 I naught. Why it will be 4 I naught? It was being explained in the last slides only. Just to revise you again. So, it was nothing but if the y1 is equal to a cos omega t, y2 is equal to a cos omega t plus minus n pi, 2 n pi. So, because cos omega t plus minus 2 n pi is always cos omega t, therefore, y2 is equal to a cos omega t, and therefore, I is equal to y1 plus y2, and therefore, y1 plus y2 is nothing but 2 a cos omega t, and hence intensity is nothing but 4 a square cos square omega t, which is equal to 4 I naught, and hence this value is being proved. So, the sign, just to explain to you what does this sign mean, the sign here it corresponds to S1p and S2p represent difference between S1p and S2p. So, this is nothing but to explain the path difference. So, this was the complete conclusion of what we can say constructive interference, and similarly for destructive interference, on the other hand, if the point P is such that the path difference, that is S1p minus S2p is n plus 1 by 2 lambda. So, just to explain, let us suppose n value is 0, then it will be nothing but L by lambda by 2. If n value is 1, then it will be 3 lambda by 2, it is 5 lambda by 2 next, it is 7 by lambda by 2 next, and so on. So, if the path difference is like this, then S1p minus S2p is nothing but n plus 1 by 2 lambda, where n can be 0, 1, 2, 3, etc. Then we will have what is called as destructive interference. So, for last was for constructive interference, this is for destructive interference, and hence the resultant intensity will be 0. In the last time it was the intensity was 4 I naught, here because everything gets cancelled up, therefore, the intensity will be 0 here. So, this was the final conclusion of everything which we learnt in the last 3 to 4 slides. Now, so this thing is done now. Now, for any other arbitrary point G, so now we explained anything. So, this was, let us suppose this is a source S1, let us suppose this is a source S2, let us suppose this is that point P being talked about, let us suppose this is the point Q being talked about, let us suppose now this is the point Q being talked about, let us suppose this point is R being talked about. Now, let us suppose there is a point G being talked about, which has some arbitrary phase phi. So, now for any other arbitrary point G, let the phase difference between the two displacement be phi. So, how is this being incorporated into mathematical formula has been talked about here. Thus, if the displacement produced by S1 is given by y1 is equal to a cos omega t, and the displacement produced by y2 would be nothing but a cos omega t plus phi. In the last lecture also, when I was concluding the complete statement, I explained to you what was the explanation of this phase difference here. So, this is nothing but the explanation of phase difference. So, let me conclude here everything only. So, this was the main first concept where S1p was equal to S2p, then Q difference to the constructive interference point, R defines the destructive interference point, and now this G defines the point having the arbitrary phase which is different from two sources. So, now let me conclude here only. From this point only I will explain in the next slide, and hence things will be contributed. So, for now let me conclude here, and thank you.